All right, so we're going to be going over what you just read about with the periodic table and arranging the elements. And the one thing that we'll keep mentioning over and over is that depending on which periodic table you're looking at, the information might be presented a little bit differently. And there's a little bit of debate on some parts. So the periodic table that I put in your reading might not look the exact same as some of the other periodic tables that we'll look at. For example, sometimes mercury is listed as a liquid. Other times it's listed as a solid, and it's kind of up for debate. But there's a lot more than just that piece that might look a little bit different. So we'll talk about that eventually. So Mendeleev, or Mendeleev, depending upon who's pronouncing it, as we know from the video that we watched and kind of the information from your book, he really looked at the periodic table, and he kind of thought of it as a puzzle. And so he put the pieces in what we now know to be a pretty accurate depiction of what those elements look like and where they are located based on their properties. So he looked at things like density, appearance, the melting point, all these other pieces. And so we have what we call periods and tables, or periods and groups that we look at. So we'll talk about that right now. So periodic means, if you think about that word periodic, it occurs or repeats at regular intervals. So it's kind of a good description, right, for this table that we're looking at. So that's why it's called the periodic table. And then we have what's called periodic law, right? It says that those repeating chemical and physical properties of the elements are going to change periodically, right, at regular intervals, like we just said, with the atomic numbers of those elements. So we can break down all those pieces, and that's what Mendeleev did, right? So he messed with the arrangements, almost like a puzzle, but the pieces didn't always fit. And he came up with three groups, which we're going to kind of attack and look at individually. So first is the metals, right? And so on the periodic table, there is a zigzag line, which I'll show you, or maybe I already showed you depending upon when I'm showing this recording. But the idea is that zigzag line helps us understand what we call the metals and the non-metals. So to the left of the zigzag line, typically things are going to be solid, and they're going to be metals for the most part. So when we look at that, that's a good way to help us understand it. So metals, you should think immediately shiny, right? Malleable. So think of like aluminum foil. It can be flattened and put into shapes. And we use this quite often in our everyday lives. They're good conductors of thermal energy, right? So they're showing you that griddle there that allows the heat to kind of stay, right? It's hot for a while. So good conductors of thermal energy. They're ductile, right? They can be drawn into thin wires. We talked about this with copper earlier this year. And so it should sound pretty familiar to us. And of course, the shiny piece for sure. And then we have what are called the nonmetals. So when we look at that zigzag line, typically we think gas, right? Or gases. So they would be typically to the right of that zigzag line on the periodic table. So they're not malleable, not ductile. They are pretty much brittle, and they'll break or shatter when they're hit with a hammer. They're not shiny. They're not good conductors, right? So they're often used as what we call insulators, right? And then we have what are called the metalloids. I always say it sounds kind of like a transformer, right? Kind of a funny word, but they kind of fit right in the middle there near that zigzag line. So some of them are shiny, others are brittle, some of them are what we call semiconductors. So they kind of conduct. They're often used in computer parts because they don't get too hot. And so they're kind of in the middle there. So that would be the third group, right? So the periods are the rows, obviously left to right, and the characteristics change as we go along. I prefer to use the word family. You will hear me address the groups as family. So those are the up and down columns, like family 1, the alkali metals, and so on and so forth, which we're going to address in the next section and kind of break it down with some reading and some videos and all of that. So that's the basics of how the periodic table is arranged.